Hamming codes. So what is the main objective of the Hamming codes? It can detect and correct single bit error. It can detect and correct. It can detect and correct single bit error. It can detect and correct single bit error. That is the objective of the Hamming code. அதாவது single bit error டிடெக்டும் பண்ணும், எந்த பொசிஷன்ன்றதையும் கண்டுபிடிச்சிடலாம். ஏன்னா ஒன்ஸ் இஃப் யூ நோ த பொசிஷன், அதை நம்ம என்ன பண்ணிடலாம், கரெக்ஷனும் பண்ணிடலாம். அதுதான் வந்து ஹேமிங் கோட்ஸ் பண்ணுது. எரரை வந்து டிடெக்டும் பண்ணும், கரெக்டும் பண்ணும். பட் நவ் சே I am having some message signal with some amount, some number of bits, say 4 bits are there. Now in this case, say this is m means 4 bits will be there. Then along with the message bits, I will be adding some extra bits, say some extra bits. I do not know how many bits now at this point. That is the parity bits. This is message, this is message, this is parity. Now we will combine both m plus k. We will combine both. Will send through the channel. So if at all if error is there, it may be in the message bits or maybe in the parity bit. That is the main problem. நம்ம வந்து மெசேஜ் கூட parity bit சேர்க்கிறோம், சேனல்ல போகும்பொழுது எரர் வந்து மெசேஜ் பிட்ஸ்லயும் வரலாம், பேரிட்டிலையும் வரலாம். ஸோ நவ் ஐ ஹவ் டு ஐடென்டிஃபை வேர் இஸ் த எரர். மெசேஜ்லையும் வரலாம், பேரிட்டிலையும் வரலாம். ஸோ நவ் how many number of parity bits I have to add in such a way, if there is a error anywhere in this m plus k, then how to identify. ஓகே, ஸோ இப்போ நான் இங்கே வந்து எத்தனை பிட்ஸ் ஆட் பண்ணோன்றதுக்கு ஒரு மேத்தமெட்டிக்கல் ரிலேஷன் இருக்கு. மோஸ்ட்லி இந்த எக்ஸாம் யூ வில் கெட் தட் மேத்தமெட்டிக்கல் ரிலேஷன். அதை பேஸ் பண்ணி தான் கொஸ்டின் வரும். கேர்ஃபுல்லாக அப்சர்வ் பண்ணுங்க. ஸோ ஐ ஆம் இன்ட்ரடியூசிங் கே பிட்ஸ். ஓகே, சப்போஸ் கே வந்து 3 பிட்ஸாக இருந்தால் ஐ கேன் பாயிண்ட் அவுட் 8 பொசிஷன். கே வந்து 3ஆக இருந்தால் ஐ கேன் பாயிண்ட் அவுட் 8 பொசிஷன். கே வந்து 4ஆக இருந்தால் ஐ கேன் பாயிண்ட் அவுட் 16 பொசிஷன். K வந்து 2 இருந்தால் only I can point out 4 position. So now that means what is the simple observation? 2 power k. So now what is the relation between m and k? I'm just forming the relation between m and k. That is the main observation here. Okay, so if I am having k bit, I can have 2 power k position identification. But how many positions available here? Only m plus k. So using 2k, I have to identify m plus k position. But again, one more condition is there. Other than m plus k position, one more condition is no error. Okay, error இருந்தால் தான் ஏதோ ஒரு பொசிஷனை பாயிண்ட் பண்ணுறோம், எரரே இல்லாமல் கூட இருக்கலாம். ஸோ m plus k plus 1. So using 2 power k, I have to point out these many number of possibilities, m plus k plus 1. That means at any point of time, 2 power k must be greater than or equal to m plus k minus 1, sorry, m plus k plus 1, or in the sum book they will give like this, 2 power k minus 1 greater than or equal to m plus k. This is very important relationship. Mostly you will get question based on this in any exam with respect to the Hamming code. So what they are trying to test, given a number of message signal, can you identify how many parity bits are needed? So you have to know this formula. Either you have to remember the formula or you have to understand the procedure. Once if you understand this procedure, you can formulate this formula at any time. Okay, so that's why understanding is very important rather than just remembering the formula. Just remember it, because there are a lot of formulas. Okay, so 2 power k has to be at any point of time greater than or equal to m plus k plus 1, where m plus k is indicating number of position. M plus k is number of position, and that extra 1 is indicating no error condition. No error condition. Extra 1 position இதுக்கு no error ன்றதையும் சொல்ல தெரியும், ஏன்னா எரரே எல்லாம் கூட இருக்கலாம். So no error position. So now along with the message bits, we are adding some parity bits. Now this we will call it as a code word in general. Okay, either in Hamming code technique or in any other technique, channel coding technique, message bits and parity bits combined together, we will call it as a code word. Combined pattern, we will call it as a code word. So now you need to know another definition. What is the Hamming distance between the code word? Hamming distance. So now I am having code word, say C1, C2. C1 means what? M1 along with the parity bits. C2 means another message bits along with the parity bits. Okay, அதாவது என்ன சொல்ல வரோம் அப்படின்னா, say for example, if m is equal to 3 or 4, if m is equal to 3, how many possibilities I can get? I can get 8 different possibilities. I can get 8 different possibilities. So I can form 8 different code word. Suppose if m is 4, length of the message bit is 4, I can form 16 different possibilities. So I will get 16 different codes. That is the idea of the code word C1, C2. Same. Now suppose I'm having some code word like this and then another code word 0. Now what is the distance between the code word? That is distance C1 comma C2. How many number of bit change is available? That is the distance between the code word, distance between the code word. So similarly, in a given system, say suppose you may be having C1 to C8, eight code words is there. You have to calculate the D minimum for all the possibilities. One, you have to compare with the remaining 7 symbol. Similarly, 2, you have to compare with all other symbols. So similarly, you have to find out different D. So again, out of that, some combination may give D minimum. Okay, one case D may be 3, in another case D may be 1. So that we'll consider as a D minimum. So minimum distance between any two pair of code words. D minimum is the minimum. Why? Because very quickly we will be using this terminology. D minimum, minimum Hamming distance. Minimum Hamming distance. So ஒரு கிவன் செட்டில் நிறைய கோட் வேர்ட்ஸ் இருக்கு, அதுக்கு இடையில நீங்க டி கண்டுபிடிக்கணும். அதில் ஏதோ ஒன்று மினிமமாக வரும். தட் இஸ் தி மினிமம் ஹேமிங் டிஸ்டன்ஸ். Okay, so before that, we'll try to understand this formula. Okay, 2 power k greater than or equal to m plus k plus 1. We'll take some example. Say they are saying 2 power k greater than or is equal to m plus k plus 1. Now, suppose if m is 4, say for example, my message length is 4 bits. If m is 4, what must be the minimum value of k? If m is 4, what must be the minimum value of k? Say for example, just trial and error I am operating. M I have chosen as 4. K can be anything. First I will put k is equal to 1. Then, sorry, m is equal to 4 plus 1 plus 1. Anyway, this is not satisfying the mathematical condition. Next, m I will put like, sorry, again m is 4 only, but k instead of 1, now I will take k as 2. Okay, if k is 2, here 4 plus 2 plus 1, again this is also not satisfying. Then k I will take like 3, 2 power 3, then 4 plus 3 plus 1. Now it is satisfying. Now it is satisfying. Okay, now it is satisfying. That means what? If m is 4, what is the k value? K has to be at least 3. K has to be at least 3. So what is the observation here? If m is 4, at least k must be 3. K can be greater than 3 also, but at least k must be 3. That is the important observation from this relationship. So அதுபோல எக்ஸாம்ல ஏதாவது ஒன்று கொடுப்பாங்க, எம்முக்கு பதிலாக வேற எதனா வேல்யூ கொடுப்பாங்க. உங்களை என்ன பண்ண சொல்லுவாங்க? கே கால்குலேட் பண்ண சொல்லுவாங்க. மினிமம் கேன்றத கொஸ்டின்ல கேட்டிருப்பாங்க. ஏன்னா கே 3 இருக்கலாம், 4, 5 ஆல் ஆர் அலவுட். பட் வாட் இஸ் த மினிமம் பாசிபிள் வேல்யூ? 3 தான் மினிமம் வேல்யூ. ஸோ இது போல கொஸ்டின்ஸ் வந்து எக்ஸாம்ல வரும். Next, so now we know what is the Hamming code procedure. Again, we may be computing this parity bits. அதை நம்ம இது போல தனியா ஆட் பண்ண மாட்டோம். இந்த parity bitலாம் இடையில போயிட்டு ஆட் பண்ற மாதிரி இருக்கும். In reality, நான் ஜஸ்ட் மேத்தமெட்டிக்கலுக்கு இது போல ஒர்க் அவுட் பண்றோம். பட் in reality, the parity bit position also we will fix. In between message, the parity bit will be added. Okay, actual method அதெல்லாம். But anyway, competitive exam அதெல்லாம் வந்து நம்மளுக்கு வராது. Only based on the formula, based on the ready-made formula, we'll be getting questions. So now using this technique, Hamming technique, in the beginning we have mentioned, okay, this technique objective is like to detect and correct single bit error, to detect and correct at least single bit error. But further, depending on the Hamming distance between the code word, further also we can detect the, again, more than 1 bit error also we can detect or correct. So in general, generalized formula, to detect S error, okay, S number of error, to detect S number of error, what should be the minimum Hamming distance? Say S plus 1. Okay, if you want to detect S S number of error, the minimum having distance in the system has to be S plus 1. Okay, if you are not satisfying this, you cannot deduct that number of error. You cannot say S is equal to D minimum minus 1. Say you are in some system, you have formed the code word. Again, between the code word, you can calculate the distance. But finally, what we need minimum distance. We need minimum distance. Suppose if D minimum in a particular system is equal to 2, that means how many number of errors you can deduct? Only one errors only you can deduct. Suppose in a particular system, D minimum is equal to 3, you can deduct 2 errors. But making D minimum 3 is not a simple job. So you have to suitably form your code words. Then only you will get D minimum as 3. Okay, that is the hidden part here. So just you have to remember the formula now. So to deduct S number of error, D minimum is equal to S plus 1. Then to deduct to correct S error, what is the formula? To correct S error, D minimum is equal to 2S plus 1, or S is equal to D minimum minus 1 divided by 2, minus 1 divided by 2. Say for example, you want to correct 2 error, then what should be the D minimum? Suppose if D minimum is equal to 5, S is equal to 5 minus 1 divided by 2, that is 2. So if you want to if you want to correct 2 error, your D minimum has to be at least 5. That is really difficult. But this is the regular formula. How many number of errors you can correct? Okay, that all depends on the minimum distance between the code word. So mostly in the exam, either you have to remember this formula to detect number of error, or to correct number of error, or otherwise regular formula. That means what is the relationship between the number of message bits and then number of parity bits. So almost we have discussed Hamming codes and then CRC also. Then finally we will see within 10 minutes, we will see the maximum likelihood deduction and then maximum a posteriori probability concept with respect to the digital